Hi there. Thank you so much for joining this course on Node.js. Node.js is an incredible platform for building high-performance networked web applications. And the really exciting part, you write your code in JavaScript, perhaps the world's most popular programming language. Node was created by Ryan Dahl back in 2009, and its early development and maintenance was sponsored by Chuyên. Over the years, Chuyên was unable to keep up pace with the development on Node.js, because of which in late 2014, a group of technical evangelists who were contributors to the original Node project forked Node into something called IOJS with the intent of rapidly iterating and improving the platform and making available latest features as being formalized under ECMAScript 6. IOJS really helped accelerate the development of this platform, and to an extent that in early 2015, the Node.js Foundation was announced with key members such as IBM, Intel, Microsoft, PayPal, Chuyên, and more. The intent was to take reins over the development and future of Node.js as a platform. Soon after, in mid-2015, both the IOJS and Node.js communities voted to join hands and merge the projects to work under the Node.js Foundation. The first official release of Node.js after its merger with IOJS has been version 4.x. The Foundation is already showing incredible promise in taking Node.js to new heights, with new versions being rapidly made available to developers and featuring not just brand new features of ECMAScript 6, but also fixing several issues related to security and performance that are key for Node's adoption into the enterprise. Unlike other programming languages such as PHP, Node is a platform. This means that you are given the ability to write code that gives you full control over your app logic and the environment within which it has to operate. You effectively write your apps from the server stack up. This gives you the incredible ability to create really cool stuff such as collaborative multi-user apps like chat servers, collaborative productivity tools, real-time games, data streaming servers, APIs for mobile apps, and basically software that needs to serve very large number of concurrent users and I/O requests. So you get a very high degree of scalability coupled with the goodness of JavaScript. Now under the hood, Node.js implements Google's incredible JavaScript engine known as Chrome V8. So what exactly is a JavaScript engine? A JavaScript engine is responsible for compiling and executing JavaScript code and managing resources and memory allocation. Written in C++, Chrome V8 is known for its amazing performance. In fact, even if you've never used Node.js, you've still been using and experiencing V8 in your Chrome browser. V8 can be made to run as a standalone program, or it can be embedded into any C++ program, thus enabling a JavaScript-based scripting interface, all the while delivering incredible performance and flexibility. This also allows you to expand and introduce your own flavor of JavaScript as needed in a specific scenario. Since V8 is a virtual machine, which means that it abstracts the underlying hardware from the actual JavaScript core by simulating a universal environment for the execution environment, you can use V8 and consequently Node.js on Windows, Mac, and Linux almost seamlessly. This is obviously great since it enables developers to deploy their apps virtually into any kind of an execution environment without worrying too much about the underlying hardware. This also means V8 is great for enterprise-grade C++ apps where the scripting prowess of JavaScript can make a difference coupled with the performance benefits of a C++ program. Now, as far as Node.js goes, V8 is implemented along with an abstraction layer called libuv, which enables Node.js to perform seamless input and output operations across a gamut of operating systems in a non-blocking way. Along with libuv, Node comes with a built-in core library that provides a host of useful methods that developers can use to write programs such as web servers and networked apps. I just mentioned that Node.js provides evented and non-blocking I/O. Let's try and understand what this jargon really means for us and why it makes Node stand out from other platforms and server scripting solutions. To understand this concept, we'll first examine the concept of synchronous execution, which is sort of how traditionally PHP would work. So imagine we have a program that has to fetch some names from a database and print them out onto the console along with the string hello users. When we run this program, the first line gets executed and invokes a method called getUsers, which runs a query on a database. For now, imagine that this was written using a traditionally synchronous language such as PHP. The interesting thing to note here is that the database query in this case would effectively block and hold up execution of the remaining script, since it would need some time to query and fetch the data as desired. So, till the result is not received from the database, the rest of the script, that is the last print statement that is supposed to output hello users, is blocked and not executed. Once the result is received back from the database, the result of the program would execute and you would see the result as shown on this slide. The execution is sequential and synchronous. For printing hello users, the preceding two tasks have to be completed first. In synchronous code, therefore, to handle a large number of concurrent requests, multi-threading is often used. Hold that thought for a moment though. In contrast, let us see how an asynchronous execution environment such as that in Node.js would look like. In this case, we have the exact same objective to the code we saw earlier. When we run this code, however, the method dbQuery sends off a request to the database in a non-blocking call to the event loop, a construct that is monitoring for events and messages in the V8 engine. It's non-blocking, so it doesn't halt the execution of the script, and we immediately see a hello users printed out at the console. At a later point in time, when the database server returns the response to the query, a part of the dbQuery method known as a callback is executed, which then displays the result. This way, the script never blocks itself. To put it in perspective, all I/O is managed by the event loop without blocking other tasks, thereby achieving optimum concurrency, a necessity when writing real-time networked apps. Instead of doing things sequentially, we do them in an asynchronous fashion. To sum up, the V8 engine inside the Chrome browser uses the event loop to monitor for user clicks and interaction, whereas on the server, the event loop in Node.js monitors for server events such as database query responses, network I/O, file I/O, etc. This makes Node.js extremely efficient and one of the major reasons why developers are excited about using it in their projects. But Node.js is single-threaded, and my server has got an 8-core processor. In the traditional programming paradigm, concurrency is typically handled by multi-threading. Here is how it works. Whenever an I/O request is received, a multi-threaded system spawns a new worker thread which handles the request. The worker thread that is spawned blocks execution till the response to the I/O request is not returned. In this visual representation, the green zones represent activity, whereas the red zones are when the CPU is simply waiting for an I/O response. These red zones are when the CPU cycles are idle and effectively wasted, as they are blocked till the I/O returns a response. Additionally, if all workers are busy, further requests would be denied. If your app requires heavy I/O, then this may not be the best way out. In contrast, Node.js uses the concept of an event loop as mentioned earlier. An event loop monitors for events. So when we need to do I/O, we send our request to the event loop. Therefore, while a response to an I/O request such as a database query or even something as trivial as uploading a file is awaited, The event loop uses the time in between for other tasks, thereby keeping the process non-blocked and available for other constructs in the program to use. This way, it achieves efficient concurrency in a single thread. When response to an IO request is received, it goes back and executes the callback code that processes the data as desired. Another thing you need to know is that in Node.js, unlike let's say in PHP or Ruby, you build your own stack from the ground up. This means writing a server stack, the app logic, and binding it with a data store like a MySQL database or MongoDB. The fact that you first have to write the code which will spawn a server instance is a unique and sometimes difficult to comprehend concept for most developers coming from PHP, Ruby, or ASP.NET environments. But as you'll soon see, it's really easy and extremely powerful to be able to do that in the first place. Imagine no LAMP stack but your own stack from the ground up. So let us try and sum up some of the reasons why Node.js is great. Node offers several advantages over traditional web stacks like LAMP or Java by providing a unique event-driven non-blocking approach to I/O. This is paramount to modern web apps that need to serve an extremely high number of concurrent requests. You also get full control over your environment because you build your own stack from the server code up. This enables you to control everything from a completely different level altogether. You write your code in JavaScript, an extremely expressive and popular language, and consequently you gain advantage from the exponentially growing number of users, companies, and the community which has embraced Node.js with open arms. Some of the biggest users of Node.js in production include Microsoft, Yahoo, eBay, LinkedIn, and PayPal. I'm also going to quote a few paragraphs by Chuyên. In his article, Chuyên sums up some of the reasons why Node.js has become the go-to technology platform for the enterprise. One of the first reasons he writes about is how developers are really excited to embrace Node.js since it is relatively new compared to PHP and Ruby, and because it allows them to leverage their existing JavaScript skills. He quotes Bill Scott, Director of User Experience at PayPal, and I quote, "Why go to Facebook and do PHP when you can go to PayPal and do Node.js?" I think that pretty much sums up how the industry looks at Node.js. On the subject of performance, Chuyên shares interesting facts. He quotes a case study where Walmart was able to leverage Node.js to handle more than 200 million users during the 2013 Black Friday period. And all the while, their servers' CPU utilization stood below 1%. This is just amazing, isn't it? Similarly, Groupon implemented Node.js and were able to see their page load times drop by 50%, while LinkedIn was able to reduce the number of servers from 30 to 3 when they replaced their Ruby on Rails stack with Node.js for handling mobile traffic. Another thing that Chuyên writes about is the fact that Node.js code is easy to maintain since it is composed up of small and manageable modules. This is something that you will get to experience yourself in just a short while. And finally, an important point worth pondering is the fact that PayPal saw their developer productivity skyrocket when they moved to Node.js. I don't think we need any more reasons to get excited about Node.js. This is a practical course, and my intent is to walk you through actual steps that are involved in writing and deploying apps in a real environment. This is most important for you as a developer to jump straight into production. So let's get started right away. Hello there. Before we begin with Node.js, I would like to take this opportunity to mention that this entire course is being gradually revised and upgraded as I speak. With ECMAScript 6 out in the wild along with Node.js 4.x, it only makes sense to completely rewrite this course from scratch. As I work towards reworking and re-recording all sections in this course, I would like to invite you to read my free ebook called ECMAScript Quick Bites, which I am writing exclusively for learners of this program. The intent is to rapidly bring you up to speed with essential ES6 features so that you can understand them when I use them in the new lectures. This would remain a work in progress project for weeks to come, and hence it only made sense to host it as a rapidly iterating document on Google Drive. I will regularly add new content to the booklet, and I invite you to share feedback with me by messaging me directly. Once it is complete, I will release a copy for everyone to download and print as well. To access this ebook, check out the Google Drive link in the additional resources section with this lecture. Also present there is a link to a spreadsheet called Update Log. This log contains the status of sections as they are being revised. Your investment in this course is of utmost importance and priority to me, and hence I'm making it a point to improve the quality of lectures based on feedback as well as standard production practices. So do keep a check on the update log for an exact status during the revision process, and do make it a point to read this ebook before you begin with the Node.js fundamentals section. And if you ever get stuck, message me directly or reach out in the forum. Happy learning!